Thank you to first of all, thank you to the organizers for having me here, giving me this opportunity of giving this talk. So yeah, let's get started. Usually I like to start this talk with a quick analogy, right? So picture yourself going to book for a restaurant, right? Usually we pick up our phones, start seeing recommendations, and what happens if you start to see that each restaurant has their own unique system for ratings? How do you even compare? And this is the exact same challenge that we are facing in crypto detection. You can see here that some of them maybe use stars, some of them numbers, or even some of them just uses emojis or words. And this fragmentation not only blocks good security and compliance, and that's why our work in SBOMs and standardizing crypto detection is so important, and with what we did in 2024. So, quick introduction about myself. I'm Matias. I work at SBOMs, where we provide open source intelligence by giving access to our knowledge base to big corporations. And by the end of this talk, I hope that you learn how to use this standardized schema and these new definitions to build up your tools and hopefully stop building the same tools over and over again. And the best of all, I'll show you some quick examples on how to get started. So, let's start with defining the impact. The impact of crypto standardization or identification, let's say, is significant across multiple fronts. As you can see here, there are a couple key stakeholders, which are security teams, trade compliance teams, companies which are increasingly concerned about post-quantum crypto, and also because auditing requirements continue to grow year over year. But there's something crucial, because when we started this journey of building our own crypto detection tools, we were spending a lot of resources and time by building these kind of tools. So by opening this up, not only saves us money, but also gives the benefit to the community of saving resources, being more efficient. So here's our proposal to the community. The Open Crypto Algorithm Dataset is a list which contains algorithm definitions, which has a simple data structure and attributes. It has a proto-taxonomy. It's written in a machine-readable format, so it's extensible. You can pipe it out into different CI/CD pipelines or whatever you need into your workflow. We even have some reference code inside the repo, so you can get started and see how it can be implemented. And something important here is that this is not only theoretical, but it's also battle-tested in production, scanning billions of files and helping big organizations to find their crypto composition. So, before diving in, these are some of the key milestones that we reached so far in the last couple of years. And let's start with the first one. So, back in 2021, we started with a simple question from one of our customers, which was basically, they were asking us if we could find or tell them the crypto composition in their code base. And you might be thinking that sounds quite simple, right? Yeah, let me tell you, it's not. And it's the same that I was mentioning before. We had this concept of scale. It's not the same doing it for a couple files, couple folders, or couple repos. But we need to do this for billions of files and thousands of projects. So, also, we realized that as more and more customers started to ask this, we noticed that this was something important and valuable to address. So, in 2022, we started with a simple start. As you can see here, sometimes simple is a smart way, right? And as simple as it might sound, we started with keyword matching. So, I hope you can see here, I think it's okay, the size of the screen. We started with a YAML definition for each crypto algorithm, where we have the algorithm name, we assign an ID, and we have a category and the security strength for each one. And as I was saying before, this was quite good for, quite effective actually for large-scale scanning. And it also was quite precise because it allowed us to differentiate between AES 128 or 256, for example. But something happened, which is our customers started to ask about non-open source projects, and new crypto libraries and frameworks started to appear more frequently than we can even track. I mean, we had to constantly update the rules or the keywords or the algorithms list. And we also realized that the customers were getting already involved. They were contributing to update the rules, to find new keywords, and also by testing in their own environments. So we noticed that why keep this private? We have something valuable, and the community was getting involved already, so we just needed to open the door. And basically, so we did. In 2024, we made two big moves. We released the dataset under C60 license, which is actually as close to public domain there is in terms of copyright law. So by this way, it wasn't just being open source, it was about making knowledge completely public. And the other big move was that even if our list was getting used or adopted as a de facto standard, we started to work with SBDX to make it an actual standard. So we have, for example, the parallelism between the SBDX licenses list, where we have the list of how we declare licenses. The same we wanted to accomplish with crypto algorithms. And as I said before, by doing this, by standardizing the way that we declare crypto algorithms in our code, we are saving time and money. So, quick demo, and I hope that this works, because usually when you do live demos, your computer explodes or something like that. So I hope that you can see the screen. Is it big enough, right? You can see it. Or it is. So, this is the repo for the crypto algorithms open dataset. So we have the definitions, where we have the algorithms, which, with each category. As I showed you before, each one of them has the algorithm, the ID, the category, and the strength. Okay. And also we have some we have one crypto detect.py, which is a script that basically utilizes these definitions to scan a given folder and produce some findings. So, let me show you here. I have this quick example, which is a Java project that we use as an example a couple times. And if I go to my terminal, I can execute a script, which basically uses the script for this folder and will output on this JSON file, and will use this folder for the definitions, the folder where the YAML files are located. Okay, if I run this, you'll see that it's analyzing. It's pretty quick. And if we take a look to the findings, we'll see that it produces a list of findings, right? Where we have, for each file, the list of matches, and inside here, we have for each match the definition file that is referring to the algorithm, and the same information that we can find on the YAML definition. Let's say we can also test another one. I have a couple funny ones here. I don't know if I set it. I think. So, same thing here. Okay. Let's go back to the other example, because I want to show you something funny. Okay, let's go back to the presentation. Okay, so there's that. And now I want to present you with some of the challenges that we are facing with this approach. As I said, keyword matching, as simple as it sounds, has its own drawbacks, let's say. One of them is, what about context? Because if we go back to findings, we have this file, hash.py, and we have two findings. One is SHA-256, and the other one is MD5, right? But now, if we go to the actual code, which is here, you can see that the code is actually commented out, right? So basically here, we are actually using SHA-256, as you can see here, and MD5 is totally commented out. So with this approach of keyword matching, we don't have that kind of context. So it will give us a false positive in this case. And the same thing here. Oh, sorry. Maybe this is an extreme example, because I don't know who will actually call their variable MD5 per day, but whatever. Just wanted to show you a quick example of the lack of context that we have with this keyword matching approach. As you can see here, we are not in a crypto context, let's say, at all, because this seems like a class that does some medication stuff for patients. But even so, it was being picked up by the script, as you can see here, and defined because of this keyword, right? So, going back. So yeah, how do we address context is one of the key questions here. Well, maybe AI could help, or maybe not. Maybe we'll introduce more convincing false positives. I don't know. I'm no expert in AI, but it's something that we have to explore for sure. But remember that the purpose of this talk is not to build the perfect crypto detection tool. It's only to show you how we standardize, how we describe these algorithms. So here's the other example. So, looking ahead, 2025 is going to be an exciting year. We are going to move this data set to the Software Transparency Foundation. So we are going to make this from company-driven to community-driven. We are going to see, for sure, new implementations in different languages. And we are going to see, for sure, the community taking ownership. So, this project gets better as more people help. And even if we all have different skills and experiences, we can make this tool stronger by contributing. And here are 4 ways of the many there are for contributing, which is help us improve the data set by adding more rules, more keywords, more libraries, algorithms, creating new implementations, as I was saying before, share some real-world use cases. We want to see what the people is actually doing out in the wild. And as I was saying before, maybe if you have knowledge in machine learning or AI, you can help us see if there's any role to play for AI in this. I mentioned restaurant ratings at the beginning of this talk. And in open source, we usually like to work together. And to make this better, we need to speak the same language. And basically, that is what this is about. We have the solution, we know it works, we know it helps the community, and we want you all to be involved. The repo is open, the tools are there, and we are really looking forward to see what you all will build. Thank you very much. If you have any questions, please.
I'll pass this one around. So, interested in your views on, like with license compliance, right? That's one thing. If I mess that up, it's a slap on the fingers, or some fines, loss of reputation in the community is probably the worst of them. But if I mess up crypto, then I go to jail. So fundamentally, like, what's your view on getting sort of customers or community onboarding for something where the consequences are that much larger? Is that sort of a hurdle you're seeing?
Yeah, I think one of the most important things that we are seeing right now as a pain point is the fact that of quantum crypto. I mean, there are a lot of security issues and risks that comes along with that. And that's why we need to at least know what crypto are in our code bases. Not only because we are going to jail, but probably we are going to jail if we mess up. But that's one of the biggest concerns right now.
Thank you. Other questions?
I had a question. So when you talked about getting a lot of false positives with the scanner, could you make the scanner as a kind of compiler front end? Then you'll get an abstract syntax tree of whatever you're scanning, and you'll be able to see that this was a comment anyway.
Yeah.
Or is that too slow? Is that the issue?
That's a very good question, and I think that's one of the best approaches that we are exploring right now. So that's very interesting, and there are a lot of open source tools out there that actually you don't have to build the ESD manually, but basically you can leverage these open source tools to to build rules against and then run that to scan the code base. That's one of the biggest approaches, or better approaches that we were seeing on how to approach this.
All right, thanks. You'll have to wait.
Sorry, Jimmy. You mentioned you worked with SPDX. Do you also plan to work with Cyclone DX and maybe others who are also trying to define SBOMs and standards? On the way, I do know that IBM has done a great job outlining some of the specifications. So, did you have a look at it? Any?
Yeah, we are aware of SBOM, but in this case, we didn't have any talks with Cyclone DX. Actually, I don't know if we plan to support SBOM generation. I think we do in the near future. But what this is about is mainly declaring just a list of algorithms. And then, apart from that, we work on the detection part, let's say. So, what is in SPDX is the list, the actual list of algorithms that is declared. And the detection part goes in another way, let's say.
So another question. I saw the recent study released by ScanOSS, or sponsored by ScanOSS, on the fact that by using Gen AI, you will introduce possibly a certain percentage of lines of code will be matches to open source. Have you seen any sort of risk that Gen AI tools will inadvertently include crypto algorithms? Is that something to be worried about and scan for?
I don't have that much knowledge on that regard, but I think Kike wrote that report from ScanOSS, and I can sure, if you have a chance to connect outside, I will surely ask him.
Great, thank you.
Welcome.
All right, other questions? No? All right, thanks again.